subscripts now. Case of E is equal to that's right, 1 over the permittivity. Or this electrostatic constant is equal to 1 over 4 pi epsilon naught. Some textbooks immediately jump into this. They bypass the Coulomb's constant. I find Coulomb's constant to be very convenient just because on the calculator, rounding off, it's 9E9. But we could also write Coulomb's constant, the force on 1 from 2, is equal to 1 over 4 pi epsilon naught Q1 Q2 over R squared R2. So just an alternate form of it. When we get to capacitors, that's when I start using epsilon, usually a lot more. But given this, my electric flux is equal to Q over epsilon naught, assuming free space, over epsilon if it's not free space. So what we have just done, we did a pseudo derivation of the following equation. The electric flux through any closed surface is equal to the charge that's enclosed divided by epsilon sum naught. That is Gauss's law of electricity. The first of Maxwell's equations.
Electricity or electrostatic?
Yes. Electricity, I first said I flipped back and forth. Electricity is generally the way it's written.
And this is Maxwell's first law.
It's the first of Maxwell's equations. Maxwell never claimed this as his. There's 4 equations, or 5 equations, but 4 are considered Maxwell's equations, that basically describe all of electricity and magnetism. And so and somewhere else after Maxwell had done his stuff, someone else called them Maxwell's equations. We will eventually get, when we get to magnetism, we'll get the second one. Then we get to when we get to electromagnetism, we'll get to the third and fourth one, and then we'll derive the speed of light, which then leads very nicely into special relativity.
What's the little thing underneath Q?
Yeah, this is the charge that's inside the surface. Now, we solved this specifically for a charge directly in the middle, but that doesn't matter. I can put the charge over here, and the electric flux through the surface is still the total charge inside divided by epsilon is 0. So I take a box. I put a 3 microcoulomb charge near the bottom, but inside. What's the electric flux through the surface? Now, for those who are gluttons of punishment, you will try to figure out what is the electric flux through each surface and then add them all together. Or for those who see the shortcut, we'll go, oh, the electric flux through the surface, well, that's just going to be 3 microcoulombs divided by the permittivity of free space, 8.85 times 10 to the negative 12. Coulomb squared per meter squared. Whatever that ends up being. Micro is 10 to the negative 6th. So we're going to put something that's 10 to the 5th. So we'll put more than 1/3, so 3.62. Someone's going to tell me the real answer.
Well, I have a question.
Yeah,
Where's the 8.85, where'd that come from? I'm sorry.
That's permittivity of free space.
Okay. Oh, is that just like regular?
Yeah.
Okay.
When I put the sub-zero, when we have epsilon sub-zero here, that is a very specific number.
Okay.
Matter of fact, I think that's one of the ones that have just recently been fixed. That they have an exact value for it now. It was recently changed within, as of the beginning of last year, this year, no, 2019, beginning of 2019, I think there were certain variables that they suddenly said we were making these exact values. So what is the real answer?
Is it just 3 on the top?
3 times 10 to the negative 6 divided by 8.85 times 10 to the negative 12.
$338,983.
300,
38.
338,000.
983.05.
So 3.39 units.
It's gonna be.
Newton meters squared per coulomb.
I hope so. We're dividing by this fraction, same as multiplying by the reciprocal. Coulomb would cancel out, and you're left with the Newton meter squared per coulomb. So given this generalization, we can now find the electric field, using this formula, of a line of charge, or the electric field of a surface of charge. And that, I guess, is gonna have to wait for a week. I know.
No, it's too
It'll be
soon.
so long.
I hope your Monday is celebrated how you want to. It's relaxing and peaceful,
Yeah.
or productive, whatever you need to do.
Please.
What's up?
I'm gonna touch on this 1 week from now.
We do have lab. We will see each other again before. Don't forget, next Friday, Fun Shirt Friday. And I will also, this was a fun shirt. And I'll read Jurassic Park.
I
Appreciate it.
participated.
What's that?
I participated.
Dave?
It's gonna be a fun trip. What's up? Take a sugar board. So this could be fun.